Here is the headlamp of the powder machines. It's used for a couple of years, and the power of the lighting is not enough, and I'm now modifying it. I use this type of LED. It works with 12 DC voltage, and it shifts to 5T. I think it's around $3 to $4 US. It has 21 pieces of LEDs. I'm going to use 18 LEDs, and I'm going to make a new enclosures, maybe using the aluminum sheets. I will removing the string gauge chips. You can see how the lead wire is soldered on the circuits, and I will cut along here and show the marking of cutting. And every 3 pieces there is cutting, so totally I will have 7 portions for this 21 pieces LED. And you must be careful in leaving up this transparent plastic material, and then chop it off a little bit by a pair of scissors. Don't attempt to damage the flexible circuit boards underneath. And this piece cut off, and these two show copper pad for soldering were exploded. Here all the 7 pieces were cut at both ends. You can see both ends, and you must take notice that there is a positive sign mark here. It's so positive, and also 12 volt. 12 volt DC. This side is positive, this side is negative. How the arrangements of the LEDs will be in your cases, and I will make the enclosures a little bit longer than original one, and then I will mark the center line here and position the center piece first, and the left hand side 2 pieces here, and these strips have the adhesives on the back, and after removing the cover papers, you stick it on the board. This is a PC board, multi-purpose. And after these 3 pieces stick up, you can continue the rest to have them in a equal spacing. Now it's done, and you need to take note of this, that they are oriented in the same directions, so you can see the positive sides on them are all on the left hand side. You can see these 2 pieces electronic on all this side, so positive on left side. And I will start to cut the board and start to solder the lead wire on them. And you mark the four screw pole holes here first before cutting, and it will they will be drilled a later times that they will be matched with the enclosure covers. And now I use back the original lead wires, and then cut an excess length here and mark the position, the spacing position with a black color marker. Now lead wire was prepared, and the holes for the lead wire to go through need to be enlarged a little bit. Use a greater milling bit. The positive lead wire was soldered, and after soldering, you have to check this if the connection is correct. I use multimeter in this lead wire end, and then contact to the positive end each wire with each point if they are connected, and also to tap on the negative side if there is any short circuit were made. After all the soldering points were made, then before connecting the voltage or power to it, you must check the connections. Make sure that no cross connections were made. Here we first gave it was here I drew a hole for the lead wire to pass through, and the first times I give it 8.5 volt. That's it. It seems it may be a little bit lower, so it flash. Yes, it lights on. And depend on where it will use by where it will use yourself, you can make more LEDs to shoot. Now the dimension of the bottom enclosures was drawn on a piece of paper with dimension, and then using those dimensions I stretch it on the 1mm thicknesses on minimum plane. Afterwards, I use a marker to draw the line on it, and the shaded area and the coarse areas will be removed, and the full line is along the dot line. After the bottom full line cut, the full line here was scratches. I use this engraving bit and then use some straight plastic material to guide, and then scratch it, and then I will flow this line to this line. As the length is not such long, so I can bend it on the wires, and I need to bend the shorter edge first in order the longer edge can be bent later. I will begin to bend the longer edges. Although the length of the wires is not enough, I think it affects a little. And in doing the bending, I will use a long piece of steel board and keep this area, so all the length will be bended at the same time, and instead of using the hammer. Here the lower enclosure covers was formed, and now we're going to make a hole here for the sliding switch, hole here for the mounting post. Is need to make 4 pieces of plastic supporter here. The shape is here and dimension here. This is the cut the pieces, and it is for the supporting the. They are for facing at the corner here to support the board, and also for screw mounting. The corner pieces will screw this using this adhesive, this jelly adhesive. Here is the dimension of the top cover. And here is the plate for the top cover. And also the LED 21 pieces. So this top plate have the hole in this dimension 7.5, and totally there is 21 pieces, and those dimensions measured on it in this plate and marked it. And I will, after cutting the outline, I will drill the hole. Later on I will bend the edges. I choose to bend the 4 edge first and then drill the holes, because after drilling the hole, the plate will not be strong enough for the bending. Now I will drill the holes for mounting the sliding switch here. And also the center hole here for mounting the flexible post. Here the hole will drill this, and for this board, the contact points here. Need to be covered with the adhesive foam, and also the other area was stick with foam so that it can fill the gap between board surface and the top cover. At the same time, if the board sit on the lower cover, there is a gap. We need to put the foam to fill them up on 4 sides. This is an option. Afterwards, we put them all together, as well as the top cover. And you can start to drill the 4 screw hole here. At the same time, the drill bit will go through all the way down the bottom cover. Actually, we don't need to down to the bottom cover. We just need to go to 3/4 of the depth length. Let's go to the plastic post, and we can mount the screw to the plastic post. Making two plastic blocks here, so that you can insert it to this depth. Another piece is here, and drill the center hole for the two mounting screw, which are in 2mm diameter. Sandwich the lower backplate, lower enclosure by these two piece blocks of plastic. After mounting the screw here, I will heat melt this orange area so the plastic will flow outside and lock these orange parts tightly. And now start to drill the two screw holes in 2mm diameter, and they will lock this by two screw nut, metal nut. Assemble these two parts together on the enclosures. I need M2 screw and screw nut here. These two parts locked by the screw. And locking screw on here, we use this type of locking plastic material screw. They are cut at the tips, so when it go into the plastic, it will cut the thread on it at the same time. Now for screw mounted on it. In addition, two supporting pillow is set here to prevent this board from depressing downwards. The central position will be mounted here. On this hole, and there is hex nut here to lock on this set. And now I need to pass this lead wire through this flexible holes. The wires connected, and the incoming wire is 8.8 volt, about around 9 volt. And it is not recommended to have a step down regulator in this housing, and you can use different type of power supply. And previously I used the laptop computers, and oldest laptop computers power supply, which is usually 9.6 volt, and actually the power supplied by it is in excess. The current draw of this lamp is 0.3 something, so it it dissipates around 3 to 4 voltage, and it's very small. And another option is you can use your stepper controller box supplies, and it is a 13.4 volt to 14 something volt. It is very high, and you need a step down converter. And as the lamp draw a little power, I think it have little effects on the stepper controller power supply. If it draw the power from it by step down regulator. The usual step down regulator is LM782012. It's very easy to construct a circuit, and use very little components. But I recommend the step down converters to be located on your stepper controller box instead of here, because it's not recommend the high voltage line to be too long and go here, and it's easy to short circuits and as a dangerous, and it's better to step down in the control box and come here. You can see and it supply a sufficient lighting to the machine. For this DIY lamps or headlight, you can decide what size of this light or how much LED lamp you need to suit your needs. You can decide a longer, more LED for bigger machines. Sometimes you may not purchase that type of LED lamps to suit your needs. So for DIY is an option to do it. Thank you for your watching.